Hello and Namaste. We'll be starting with the rectification length of a plane curve Cartesian form part 1. So in this particular part we'll be introducing with the what exactly the rectification means and the questions. Length of a curve in a arc in a Cartesian form is nothing but the process of determining the length of an arc of a plane curve. That means, suppose for example, we have got a function y equals to f of x and this particular length of this particular curve we have to find it out, which is from x is equals to a to x equals to b. Then this is nothing but ds upon dx is equals to square root of 1 plus dy upon dx the whole square. And if you'll find out the length of this curve from a to b, then this can be given as integration from a to b square root of 1 plus dy upon dx the whole square dx, which is nothing but this is the formula for the curve y is equals to f of x from x is equals to a to x is equals to b. If you wanted to find out the length of the arc or a curve, x is equals to f of y from y is equals to c to y is equals to d, then it has been given to us as integration from c to d square root of 1 plus dx upon dy the whole square dy. These are the two different formulae we'll be using it in the Cartesian form to find out the length of the curve if it has been given as y equals to f of x or it is from x is equals to f of y. Let us make a move towards the first question. Show that the length of the arc of a curve a y square is equals to x cube from the origin to a point whose abscissa is b. That means what this abscissa means, it's been the coordinate of x or x coordinate of that particular point. It's given to us by this particular value. Now the length of, or you can say the curve has been given to us as this, that is a y square is equals to x cube. If you'll observe here, this type of curve we'll be getting it up. And now, sorry, if we'll differentiate this with respect to x, we'll be getting 2ay dy upon dx is 3x squared. That means it's nothing but dy upon dx is equals to 3x squared upon 2ay. But we do not want any y into this particular value because if you observe the formula, we have only the values or the function of x. Therefore, this y can be replaced as square root of x cube upon a, that is nothing but 3 by 2 square root of x by a is the value for dy upon dx. Again, this point, this arc OP varies from 0 to B as we have already said that. Therefore, the length of the arc OP is nothing but given by this particular formula, putting the value of over here, that is dy upon dx is nothing but 3 by 2 square root of x by a, but it is a square, so it becomes 9 by 4 x by a. 9 by 4 x by a dx. Now, if you'll observe here in this particular way, this square root of can be written as 1 plus 9x upon 4a to the power 1 by 2, which can be integrated further from 1 plus 9x upon 4a, this raised to 1 by 2 plus 1 upon 1 by 2 plus 1 into 9 upon 4a. And of course, this limit is from 0 to b over here. Similarly, if we'll go ahead and just simplify further, this is 1 by 2 plus 1, which is coming out to be 3 by 2, which is nothing but 2 by 3 over here. Similarly, this 9 upon 4a can be written as 4a by 9, and therefore this is just by putting the values we'll be reaching towards this answer. This is a very simple, we can simply say that because the lower limit is coming out to be 0 whenever the x is coming out to be 0, the upper limit is just getting replaced. This x by b will be reaching to the answer as 8a upon 27 into 1 plus 9b upon 4a to the power 3 by 2. This is what is the answer. We need it in this particular example. Moving ahead to the next one, show that the length of the arc of a curve 4ax is equals to y square minus 2a square log of y by a minus a square from the point 0 comma a to the point 4 comma y is given by y square upon 2a minus a by 2 minus x. Now, if we'll observe here, this is the value which we need to find out or show that the length of the arc from these 2 points. Now, the difference between this first and the second question is, if you'll observe here, in the LHS we have got x and we do not have any other x present over here in this curve. That means we have to differentiate this particular equation or LHS with respect to x. That means this curve is given to us as x is equals to f of y type. and therefore we have to differentiate this particular curve or equation with respect to y. So which is 4a dx upon dy is 2y minus 2a square into y, a by y into 1 by a. If you'll observe, this can be written as dx upon dy, which is y square minus a square upon 2ay. Again, in this particular, as I've told you, this is x equals to f of y, so we need to have the limit of y. So now in these 2 points, the y is moving from a to y, and therefore y is varies from a to y, and therefore this is s is equals to the equation, or the length is nothing but integration from a to y square root of 1 plus dx upon dy the whole square dy, which is nothing but just putting the value of dx upon dy over here, which is coming out to be this. Similarly, just go on doing it or reducing this further. My suggestion for you, just pause it over here, try to get the answer which I'm getting it in the using the integration. So this is nothing but we'll be getting just by separating the terms and just doing the integration, we'll be reaching towards this point. Now, in this particular, we have to note it down that we do not have any log term, but we do get it here, the log term over here, but we can replace it. Just observe this equation, given equation over here, Now from here, this equation, we'll be taking it out, this minus 2ay log of y by a to the one side and other terms on the other side. That means, in short, we are finding out the value of a square log of y by a by minus 2ax plus y square by 2 plus a square by 2, and we'll be replacing that value over here. Actually, this is a plus over here, and because we are dividing this with the minus 2, I think this is this is as a minus, because it's a minus plus plus plus. Okay, this is a minus, and that's what we are getting it a minus a square by 2. So we are just replacing the value of a square log of y by a by this y and the terms, and just adjusting the terms, will be getting this answer, and we are reaching towards the final answer which we are expecting here as the final answer for the question. Now this is the way to go ahead and find out the length of the curve. This is just a part 1. Part 2 will be little difficult and little the concepts ahead than what we have studied in this particular session. Stay tuned, stay connected for the upcoming sessions. Thank you. Happy learning.